And now we look at problem 1.2. The problem states that a discrete time signal x of n is shown in figure 119. And the question is sketch and label each of the following signals x of n minus 2. So first and foremost, what I have done is to mathematically express this function of x of n, as you can see here. So the first one is that as we said, the convention is that the point when n is equals to 0 is showed with an arrow. But for me, that doesn't even help me very much. The best way to express it is to express it in a mathematical form, like what is the value of xn when for a given range of n. So what we observe here is that n or x of n is equals to n for n is 0 or between 0 and 3. So you can see n is equals to 0 when n is equals to, okay, x of n is equals to 0 when n is equals to 0, is equals to 1 when n is equals to 1, 2 is when n is equals to 2, and 3 when n is equals to 3. So that is my first expression, that n is equals to, or x of n is equals to n for this range that we have just seen. The other one that I observe, and sometimes you can label our equation the best way we know how, is x of n is equals to 0 for n is greater than or equals to 5. So we can see that when n is greater than 5 or equals to 5, the function goes to 0. And you can see for the -1 and for -2, I am assuming it is going like that. And therefore, that reason I have said for n is greater than or equals to 5, we say that that is when n, our function goes to 0. And on the negative side, when n is less than or equals to -1, again, our function goes to 0. Lastly, I have defined that n is equals to 3, this value, when n is equals to 4. And for that reason, therefore, we can try to evaluate our first function when x, for a function of x of n minus 2. All we do is to introduce our x of n minus 2, okay, n minus 2 everywhere n was. So we had said that in the first place it is equals to n, therefore it will be n minus 2. X of n will be n minus 2, and therefore the range changes again for -n minus 2 to 0 to 3. And what we simply do is to express it exactly the way it was before, but now with n minus 2 replacing n. And what we observe is that when we solve for n on either side, this remains as it is. But now when you plus 2 on both sides, we have our range changing from negative or from 2, +2 to 5. And therefore, of course, the same thing happens. This is 7 plus 2 here. You have 7 is less than or equals to n, and n is less than or equals to 1. So we are actually defining that range. And lastly, n is equals to x of n minus 2 will be 3 when n is equals to 6. So as you can see, for our first range 2 to 5, we have n. When n is equals to 2, our function will be n minus 2. Our n is 2, so 2 minus 2 will become 0, and therefore our function will be 0. Then 3 minus 2 will be a 1, and therefore we have a 1 there. 4 minus 2 gets us a 2, and 5 minus 2 gives us a 3. So you can see clearly that we have matched our 5, our 3, 2, 1, and 0. And lastly, the one that even confirms for us the solution is that is equal to 3 when n is equal to 6. And as you can see, is equal to 3 when n is equal to 6. All we can see here clearly is that this is a time shift to the positive side. So we shifted our function towards the right by 2, or by a delay of 2. And moving to the next section is that the next section asks to evaluate x of 2n, and I've just done it here again. We replace n with 2n everywhere. So here we had n, we have 2n, and in this range we had n, we replace it with 2n, and everywhere else as such. What we therefore do is that our n must be resolved to without any function, and therefore what we observe is that we divide both sides by 2 here. We have 0 is less than n is less than or equals to 1.5. And again, 0 is less than 2.5. So this is supposed to be n. N and n is less than 1.5. Divide both sides by 2. Supposed to be 0.5 less than or equals to negative 0.5. And lastly, our divide by 2, you have n is equals to 2. So that is when you have 3. So if you start with this one in our figure B without even drawing, you can say that x of 2n will be equals to 3 when n is equals to 2. So we go to 2 and we can see this is our 3. 2n when n is equals to 0, 0 times 2 becomes mean 0, but when n is equals to 1 within this range, we can see that 1 times 2 becomes 2, and therefore we have 1 times 2 here becomes 2 here. So that is satisfied. We have only one term because n only, or a function only exists where we have integers. Therefore, since this is not an integer, we have to take the lowest one, which is 1. And lastly, it is 0 when n is bigger than 2.5. So when I say bigger than 2.5, we're actually saying that bigger than 3, bigger than or equal to 3, which is the highest. Therefore, we pick 3 there, etc. And on the other side, negative 0.5. So if we take negative 1, then we are going to be going 0 on the left. So that is how we represent x of 2n, as you can see in this figure. The key point to observe is that sometimes you cannot do this unless you're able to express it using mathematical expression. Number C asks express x of minus n, and a minus n, again we replace n with minus n there, minus n there. And what we do is that we solve it down here, as you can see. And we can say that this remains minus n, but when you change both sides with negative, you can see now we are changing the limits. This comes on this side, and 0 goes on the other side. So we have n is less than or equals to minus 3, and is less than n is less than or equals to 0. And again, 1, this 1 now comes positive. When you multiply by a negative, this changes sign. As I showed you earlier, this becomes positive 1, comes on this side. Therefore, n will be bigger than or equals to 1, and will be bigger than, or it is less than or equals to negative 5. This is negative 5. And lastly, it will be equals to 3 for n is equals to negative 4. Therefore, we can see this in section C. You can see that we can start even with the last one. It is equal to 3 when n is equals to negative 4. This is a 3 clearly. And if you are now to evaluate this one, negative n for n is greater than or equal to 0. So when it is 0, you say negative 0 is equals to 0. Negative 1 times negative, this negative becomes positive 1 there and there and there. So we can clearly confirm that that expression 3 is obtained, or expression C is obtained as such. And again, as you can see, it would be almost impossible to express this function unless you are able to express it mathematically. And I presume you can do the same thing for x of minus n plus 2. And the same thing. This is the only thing, except that it has now been shifted towards right. So yeah, I think that covers problem 1, 2, and you can express the same thing and you find it there.